1.1, we need to determine f prime of x from first principles. Therefore, our formula is given by f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So what we need is to substitute f of x and substitute f of x plus h and then simplify. Already we know that our f of x is 2x squared minus 3x. Then what will be f of x plus h? Then in place of x, we substitute x plus h. We do the same thing on the right hand side. 2 into x plus h squared minus 3 into x plus h. Then we simplify. We get into x squared plus 2xh plus h squared minus 3x minus 3h, of which this will be equals to 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And then now that we have the expression for x plus f of x plus h, we can now substitute into our formula. Then we say the limit as h approaches 0 of f of x plus h is 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus, and our f of x is given by 2x squared minus 3x, and this is all divided by h. Then we say equal, and then we still bring down the limit as h approaches 0, and then we simplify our numerator. We'll have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x, all divided by h. And then on the numerator, 2x squared minus 2x squared is 0, minus 3x plus 3x is 0. Then this will be equals to the limit as h approaches 0 of 4xh plus 2h squared minus 3h, all divided by h. Then this will be equals to limit as h approaches 0. Now, on our fraction here, we can simplify it as we are having 4xh plus 2h squared minus 3h all divided by h, which can be simplified as what? 4xh divided by h minus plus 2h squared divided by h minus 3h divided by h. Then this will be equals to, then h divided by h is 1, h squared divided by h will be left with h divided by h is 1. Then we get limit as h approaches 0, then we'll be left with 4x plus 2h minus 3. And then now that we no longer have h in the denominator, then we can substitute 0 for h and drop the limit. Then we get 4x plus 2 into 0 minus 3. Therefore, our f prime of x, will be equals to 4x minus 3. Then we are getting 4x minus 3. Right, and question 1.2a. 1.2a, we need to determine what? dy dx. If y is equals to 4x to power 5 minus 6x to power 4 plus 3x. So A, we need to determine dy dx, the derivative of y with respect to x. Question 1.2. We're having y is equals to 4x cubed minus 6x to power 4, 4x to power 5 minus 6x to power 4, 4x to power 5, not 4x cubed, 4x to power 5 minus 6x to power 4 plus 3x. And from that, we need to determine dy dx plus 3x. Meaning we need to find the what? The derivative. Then the derivative with respect to x. Then immediately we check the expression on the right hand side. If each and every term is in the form that it can be differentiated, meaning it is in the what? In the power form, where maybe we can say in the form ax to power b, where a is a real number and b is a real number. Then we can see that each and every term with x, it is what? In power form. Therefore, we are ready to differentiate. Then we can say now we can find dy dx. It will be equals to, then the derivative of 4x to power 5, 20x to power 4, minus 6x to power 4, minus 24x cubed, 3x plus 3. That will be the derivative for 1.2a. 1.2a. And then 1.2b. 1.2 now b. We need to find what? We need to find the derivative of the expression inside the square bracket, which is negative cube root of x divided by 2. Find the derivative of dx, negative cube root of x divided by 2 plus 1 over 3x all squared. 1 over 3x all squared. Now the question is the expression inside the square bracket, we are having what? Two terms. Term number 1, term number 2. Are those two terms ready to be differentiated? They are not. Term number 1 is not in power form, also term number 2. Therefore, we need to simplify each of those terms so that they are in power form. So, as we simplify, we bring down what? Dx. We say dx, then negative cube root of x is x to power 1 over 3. Then this is divided by 2. Plus 1 over 3x all squared is the same as 1 squared is 1, 3 squared, 9x squared. Equals to, then term number 1, now inside the square bracket, it can be differentiated. Term number 1, let's make this example where you are having what? X divided by 2. It is in power form as what? As this can be simplified to what? 1 over 2 multiplied by x. You see? 1 over 2 multiplied by x. So that one can be simplified just like that. But term number 2, which is this one. We are having what? X squared term in the denominator. Therefore, we need that x squared term to be in the x term to be in the what? In the numerator. Therefore, we are going to multiply 1 over 9x squared by what? By x minus 2 divided by x minus 2. Then we will have dx. The first term we simplify it as minus 1 over 2 multiplied by x to power 1 over 3 plus, and then 1 over 9x squared multiplied by x to power minus 2 divided by x to power minus 2 will be 1 over 9 multiplied by x to power minus 2. Then we say equals to, and then from there, now all the terms inside the square bracket, they are ready to be differentiated. Then we can differentiate, and when we differentiate, we now drop the what? The dx. Then we can say the derivative of minus 1 over 2 multiplied by x to power 1 over 3 will be minus 1 over 6 x to power negative 2 over 3. And then the derivative of positive 1 over 9 multiplied by x to power minus 2 will be minus 2 over 9 multiplied by x to power negative 3. And then you can leave your answer with those what? Negative exponents, unless the question says leave your answer with positive what? Exponents. But otherwise, you can just leave it here. If maybe for argument's sake the question said leave your answer with positive exponent, then you will further say this will be negative 1 over 6x to power 2 over 3 minus 2 over 9 x to power positive 3 minus 2 over 9x to power positive 3. But if the question does not say leave your answers with positive exponents, then this is where you should stop. Right, that's it with question 1.